Hello all, welcome to this course on Elements of Mechanical Engineering. My name is Atchuta Ramacharyulu and I am working as an assistant professor in the Department of Mechanical Engineering. In this lecture, we are going to see the introduction to a milling machine and how different types of operations can be performed on a milling machine. Currently, we are in the fourth module where we are studying different machine tools. The module name is Machine Tools. So in this, we have already studied lathe machines and different types of operations that can be performed on a lathe machine. Now in this lecture, from this, we are going to start milling machine. So first of all, what is a milling machine? A milling machine is a type of machine which removes the material from the workpiece by feeding the work past a rotating multi-point cutter. So the milling machine is also very similar to a lathe machine where it is used to remove the material from the workpiece. But in milling machine, we have a multi-point cutting tool, whereas in lathe machine, we have a single point cutting tool. So this is the only difference between a milling and lathe machine. And also the construction is also different in the case of milling machine. We have vertical milling machines, horizontal milling machines and different operations that can be performed on a milling machine. Now, the metal removal rate is higher, very high, as the cutter has a high speed and many cutting edges. So, the metal removal rate is very high in these machines when compared to lathe machine. In lathe machine, the metal removal rate is very low because we have a single point cutting tool. It has limited capability. Whereas in milling machine, we have multi-edge cutting tool. We have a tool which have multiple edges, which is responsible for removing more amount of material at a higher speed also. When compared to lathe machine, we can remove the metal. Your chipping formation is seen here more rapidly, and the process of machining will take lesser time here in milling machine. It is the most important machine in tool room as nearly all the operations can be performed on it with high accuracy. When we compare to other machining equipment that are related to manufacturing industry, this machine, the milling machine, is very important because most of the applications, most of the operations can be performed easily on this machine. Okay, and now let us see. So this is the figure of a milling machine where we can see front view and side view. See, there are many parts which are required to do machining operations. So see here, first part is overarm. So this figure is showing a vertical milling machine, whereas horizontal milling machines are also there, which we are going to study shortly in the coming slides. As of now, this is a vertical milling machine and it has many parts which are shown in red color. So see, in the front view, we have the first one, that is overarm. So overarm is a cast iron part which is made in order to hold the workpiece or the tool. So it is used to hold the tool post. So the tool post is attached to this. And then we have arbor bracket. So this arbor bracket is nothing but it is a device which is used to hold the workpiece arrangement. I mean the tool post arrangement will be attached to this bracket. And then we have arbor here. So the arbor is nothing but this central cylindrical rod on which a wheel is attached, on a tool is attached, is called arbor. And then we have a cutting tool here. This is the cutting tool which is responsible for removing the metal from the workpiece. And then we have machine vise. So the machine vise is nothing but it is the place where the workpiece is fixed. So this dark colored piece is called workpiece. So workpiece is the metal piece on which we are working. Okay. And then we have cross traverse handle. So we have different movements that are possible on this milling machine. So this particular handle is responsible for traverse motion. Horizontal motions are possible, and this lower handle, this is possible, or this lever is the by operating this lever we can make vertical traverse motions. Okay, vertical motions are possible by rotating this handle, and horizontal motions are possible by rotating this handle. And also we have feed giving wheel. This is the feed giving wheel which is operated, and we can give feed, we can move front and back. So these are the parts which are in the front view. And then in the side view we can see there is a table. This is a table actually. On the end of the table we have a handle. This is feed handle with which we can give feed. So that you can see this is the workpiece. This workpiece is attached on the machine wise, and this machine wise can be moved. It can be moved in up and down direction, front and back direction, and also we can give feed. Feed means we can move it in the horizontal direction. So when compared to a lathe machine, this milling machine has 3 directional motions. Whereas in lathe machine, we can give only 2 types of motions. One, feed, and second one is depth of cut. Okay, these 2 motions are only possible in the case of a lathe machine. But here in milling machine, we have 3 motions possible. First one, traverse motion, and then we have vertical motion, and after that we have feed. So feed, all the 3 motions can be combinedly working together to form or to machine a particular workpiece. So in the side view we can see there is a table and feed handle. Feed handle is responsible for moving the entire table in the horizontal direction. Okay, this table can move in this direction by rotating the feed wheel. And then let us move to the coming slide. So let us see what are the basic parts of a milling machine. So the parts of a milling machines are like first one, base, where the entire structure is built. So the base is the part upon which the machine parts are being mounted, and it is a type of foundation for the machine. See here in the picture, you can see this is the base. On this base we have this entire structure. This entire structure is based on, it is built on the base only. And then the base is mostly made up of cast iron. Okay, the base is made up of cast iron. So it has a good strength and rigidity because it is cast iron. It is very heavy also. It also helps in absorption of shocks. Cutting fluids can also be stored in the base. So the base is so huge that it can be used as a functional purpose. Not only a solid base, it has openings, or it has some shelves where we can put cutting fluids also. And then the second part is column. So the column is the second part in the milling machine construction, where it is the main frame which supports, it consists of all driving mechanisms and the motor. Okay, in the picture we can see, I'll remove all the markings. So this part is nothing but the column. So inside the column we have gears, motor, and all the moving mechanisms are present inside the milling machine. Milling machine's column. So the driving mechanism usually consists of cone pulley mechanism, in which the V belt is being used to connect it to the motor. So in milling machine, we have a cone V belt pulley arrangement. We have a cone pulley on which a V belt is attached. The V belt is attached in turn to the motor, where the rotating motion is being transported to the particular moving tool. Okay, see here in the picture, this is the tool. This is moving. The tool will be moving in this machine, whereas in lathe machine the workpiece will be moving. Here the workpiece is constant. It is kept constant throughout the process. Okay, and then Further, by using this driving mechanism, the speed of the machine can control as per our requirements. So the speed of the driving mechanisms can be changed. This is a similar option which is available in lathe machine. So in lathe machines also, we can actually change the speed of the head stock, by which we can change the speed of the workpiece. So the workpiece will be rotating at a higher speed. So similarly, in the milling machine, we can change the speed of the tool which is rotating. So we have pulley arrangement which is connected to motor with the help of V belts. We can change the speed. Okay, we don't require the same speed for all the kinds of workpieces. Okay, and then we have third part is knee. So knee shape is quite similar to that of a human body. Okay, you can see in this picture. This part is called knee. This entire part, it is very similar to human knee. Okay, so the function of this knee is the important part which supports the other parts like saddle and table. Okay, it supports the saddle and table. Saddle is the part which is on which we will mount the workpiece, and table is also responsible for the feed movement. Okay, so the knee it will support the saddle and table. It is attached to the column and has guide ways by which it can move up and down with the help of elevating screw for adjusting its height. Okay, the column has guide ways, so we can understand this milling machine is so huge. Okay, it is very large in size when compared to a lathe machine, and it has a column attached and has guideways. It has some guideways on which this saddle and table can move. Okay, depending on the size of the workpiece on which we are working, we can actually move this saddle and we can lock it at some point on the guideways. So this is for the adjustment of height. We can use different adjustments can be possible on the knee. And then we have fourth part, that is saddle. So the saddle is present on the top of the knee, which further carries the table. Its basic function is to support the table. You can see in this picture, this part is nothing but saddle. Okay, this arrangement is called saddle, and on the saddle we have this table. This table is there. On the table we have a chuck, machine wise, in which the workpiece is fixed. Okay, so this is the saddle. So a saddle can slide on the guideways which are exactly 90 degrees to the column face. See, in the side view we can see this is the column. So this is the column and this part is called the column, and we have guideways which are perpendicularly mounted on this bed. So on this bed, this saddle can move. Okay, in the side view we can see that the saddle can move into the towards the column or away from the column. Okay, this type of motion is possible for the saddle. Okay, and then saddle moves crosswise on guideways provided on the knee. On the knee, the crossways are also provided so that this saddle, it will move in the horizontal direction also. Okay, depending on the size of the workpiece we are working on, we have to adjust the position of this saddle. So saddle is the part which is holding the table. On the table we have bench wise. On the bench wise or machine wise, we have to insert the workpiece. So the saddle has the capability of moving in both X direction and Y direction with respect to the bed. Okay. So on the saddle we have table. And then finally we have table. So the table is the part which is responsible for holding the machine wise. On the table with respect to saddle, it can also move. When we want to give feed, okay, we call the movement of the machine tool or the workpiece with respect to each other. This movement is called feed. When we want to give feed, we have to move the table only. Okay, by operating a lever, we can simply move the table in horizontal direction. So the table is present on the top of the saddle. The table consists of T slots or sometimes fixtures are used for holding up the workpiece on the table. Okay. So the workpiece on the table, it has to be fixed in the machine wise. So the table should be moved in guideways again, or sometimes it is fixed with fixtures are used for holding the table in place. Okay, a table can travel longitudinally in a horizontal plane. Okay, a table can travel longitudinally in a horizontal plane, and then the next part is overarm. So overarm, it is also called as overhanging arm. Overarm is present at the top of the column. The basic function of the overarm is to support the arbor and spindle. Let us go back to the figure again. So in the front view, we can see this is the overarm. So this overarm is attached to the column. So it will be hanging from the column. Okay, what is the function of it? It is used to hold the arbor. So this is arbor. We have seen all the parts. Also the cutting tool which is rotating. This tool is also attached to the overhanging arm only. Okay. So overhanging arm or overarm, it is responsible for holding the arbor and the spindle on which we have a tool which is rotating. And then we have spindle or arbor. What exactly spindle is? Spindle, it is in the top portion of the column. It is attached to the overarm, and see here in this picture, this is spindle. Okay, this is spindle. It is attached into the column, which is in turn attached to the electric motor which is rotating, and this spindle is responsible for the rotation of the tool. Okay, the spindle is also an important part of the machine, as it is the part where the multi-point cutter is attached. Okay, the spindle only, we have to attach the multi-point cutting tool. It is like a wheel. It is, in this case, in this figure, we can see this is a wheel. It has multiple cutting points. So this multiple edge cutting tool is fixed on the spindle only. Okay, spindle is the one which is rotating along with the multi-point cutting tool. So this multi-point cutting tool is responsible for removing the material from the workpiece. We have already studied that the multi-point cutting tool, it has multiple points, whereas in lathe machine it has only one point of cutting edge. So because it has multiple cutting edges, it is responsible for removing more amount of material in lesser time. Okay. Now let us see the working principle of a milling machine. So the milling machine employed in the metal removing operation, in which the work is rigidly clamped on the table of the machine, and the revolving cutter which help multiple teeth is mounted on the arbor. And then the cutter revolves at higher speed and the work is fed slowly past the cutter. The work can be fed in a vertical, longitudinal or cross direction depending upon the type of milling machine being used. As the work proceeds, the cutter teeth removes the metal from the surface of the job to produce desired shape. Here we have to be very careful. This is unlike lathe machine, we have to adjust the position of workpiece. See here again we are back to the diagram. So in this picture we can see a lathe machine, a milling machine. We have both side view and front view. Okay. In lathe machine, what we do? In lathe machine, the workpiece is attached to the spindle which is rotating at higher speeds, whereas the tool is controllable. Like we can move the tool in horizontal or vertical direction. In some time, if we want to do taper turning, we will keep the tool in an inclined position and then we will give it the feed. Okay. There are only two motions possible in lathe machine, that is giving the feed and giving the depth. Whereas in milling machine, we can give three motions: traverse, longitudinal, it's not longitudinal, it is vertical, and then we can give feed also. Okay, there are three types of motions possible in the case of milling machine. So unlike lathe machine, here the cutting tool will be rotating. Okay, see here, this is the spindle, and on the spindle we have a cutting tool which is rotating at very higher speed, because we have connected this spindle to the motor, electric motor, which is rotating through the help of a belt. So see here, the tool will be at a stationary point. The tool is only rotating, but it cannot move in any direction. Okay, the tool is fixed, but it is rotating. Even though it is rotating, it is fixed at a particular junction. Okay, this tool, it cannot move up or down, it cannot move left or right. It is fixed at the particular position. The only thing which is movable, the only thing for which these three motions are possible is the workpiece. The workpiece which is attached on the table, which is in turn placed on the saddle, which is based on the base. Okay, so this entire arrangement, this can move in all the three directions. This part, both in front view and side view, we can see the saddle is the one which can move in upward, downward, left, right, forward, backward. So all the three-dimensional movement is possible for the saddle only. Okay, we can make the saddle to move towards the tool. Then we can give some feed. So the working of this milling machine is more complex than the lathe machine, because milling machine requires the movement to be controlled in three-dimensional space. So forward, backward, left, right, which is feed, forward, backward, which is traverse, up and down, which is vertical. So all the three motions has to be controlled by the operator. So that is why we can do so much different types of operations are possible on the milling machine. Okay, so this is all about the working principle of milling machine, and this is done. And so when we compare the milling machine with other machines like lathe machine, okay, so milling machine has wide range of applications when compared to a lathe machine. So that is all for this lecture. In the coming lectures, we are going to see some more applications and different types of operations that are possible on a milling machine. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.